Good morning. My name is Jennifer Barczyszyn and I'm a teacher at Shadow Ridge High School, and today we're going to look at the geometry concepts, parallel and perpendicular lines. As we get started here, I want to go over some concepts before we start looking at specific examples this time. So I would like to first of all start about 5 different concepts that are important for parallel and perpendicular lines. The first thing I'd like to talk about is slope. And slope is recognized by most of you as m, and it's equal to rise over run, which is the same thing as the change in y over the change in x, or more importantly, it's also known as y2 minus y1 over x2 minus x1. And if you're asked to calculate the slope, basically what will happen is you'll be given 2 points, and you can use y2 and y1 and x2 as x1. Those are going to represent the x and y coordinates of the points that you're given. You would simply substitute in those values and then simplify to come up with the slope. When dealing with slope, a lot of problems will ask you about parallel and perpendicular as well. And if we look at parallel or perpendicular, we know that if 2 lines are parallel, that means they have the same slope. And if 2 lines are perpendicular, that means that their slopes are opposite reciprocals. Now, opposite reciprocals, let's go over that just real fast here. If you think of something having an opposite reciprocal, I'm going to start by giving you a slope of a line that is 2 over 3, 2/3. If I asked you to come up with the slope of the perpendicular line slope is going to be the opposite, which means it has to be negative, and the reciprocal means that we simply change the numerator and the denominator. So if you look here, we had 2/3, and our perpendicular slope becomes negative 3 over 2. Now be careful, because if you start with a slope that is negative, for example, negative 2 over 5, then your perpendicular slope, the opposite will be positive, and the reciprocal says change the numerator and denominator. So the perpendicular slope is 5 over 2. When we're also studying parallel lines, we have to have our equations of our lines, because a lot of times they'll tell us to find the equation of a line that passes through a given point and is parallel to a given line. So there's 2 linear equations that I want to discuss first before we start our problems. We have our point slope form. Point slope form means basically if you're given a point and a slope, you can just substitute the values into y minus y1 equals m times the quantity x minus x1. Notice x1 and y1 represent the point that you're given, and m represents your slope. We also have slope-intercept form, and this is probably more commonly used. Slope-intercept form is y equals mx plus b. So there's kind of a summary of the 5 key parts that you're going to need to know in order to be successful with your geometry problems related to parallel and perpendicular lines. So now let's look at a couple of examples. The first 2 examples tell us that we're given line L that has an equation of y equals 2 over 5x. So first, right there, basically if this is in y equals mx plus b form, we know that our m is 2 over 5, and because I have no b, my b or my y-intercept would be plus 0. So notice, the m is 2/5 on this problem. So to look at my first example, the slope of any line parallel to L is 2/5. And we know from our previous lesson that we have a slope of 2/5. The parallel is 2/5. They're equal. Therefore, I know that this is a true statement. This next example says the slope of any line perpendicular to line L is 5 over 2. So our given slope from line L is 2 over 5. And I know that if I look at a perpendicular slope, it has to be the opposite reciprocal. So opposite means it's going to be negative. Reciprocal means I'm going to change the numerator and denominator. And so I have that the perpendicular slope should be negative 5 over 2. Well, our problem says it should be 5 over 2, which is not correct. Therefore, this is going to be false. Let's look at one more example dealing with slope. On this particular problem, this problem says the slope of PQ is 2/3. Point M lies 1/3 of the way from P to Q on segment PQ. What is the slope of PM? So there's a lot of information there. Let's take this one sentence at a time and kind of draw so that we can understand what we're looking at. They don't give us a starting point, so I'm just going to randomly choose a point to start from. And I'm going to read my first sentence. The slope of PQ is 2/3, which means rise over run, so I'm going to go up 2 and right 3. I'm going to go up 2 and right 3. And I'm going to do that just one more time so that we actually have a good line that we're looking at. So if I connect this, you can see that that line has a slope of 2 over 3. And we can represent this by PQ. The second sentence states, line M lies 1/3 of the way from P to Q. So notice, I did this slope once here, I did it a second time here, and I did it a third time here. So point M would have to lie right here. Because point M lies on this same line, that means it has to have the exact same slope that the entire line has. Therefore, the slope of PM is going to be 2/3. Okay, one last example here to deal with parallel and perpendicular lines. This example that I want to focus on is asking you to write an equation of a line. And therefore, there's two different linear equations that we discussed to start this broadcast. We discussed y equals mx plus b, and this is slope intercept, or y minus y1 equals mx minus x1, and that's point slope. So let's look at our problem and see what we're given. Which equation describes a line passing through -3, 1 and is parallel to y equals 4x plus 1? So the first bit of information is I have some point -3, 1, and then because it says parallel to y equals 4x plus 1, because it's parallel, I know that the slope has to be the same, and this given equation says that my slope is 4. Now, based on the given information, it would be my first reaction to try and substitute this into my point slope. I'm given a point, I'm given a slope, therefore I would use this equation here. Y minus. Now, before I make my substitutions, I always recommend to kids to label their points. That way you don't make your substitutions incorrectly. Y minus y1, y1 is 1, equals m, we're substituting in 4, x minus x1. Now x1 is -3. So you have minus a negative, which is going to turn that positive. Our first step to solve this to get it to y equals mx plus b, or slope-intercept form, is to distribute the 4 to both terms. So 4 times x is 4x, and 4 times positive 3 is 12. And then to solve for y, I simply want to add 1 to both sides. So by adding 1 and simplifying, y is equal to 4x plus 13. At that point, we can now look, because I want to just try a second method here. I want to show you that if I used y equals mx plus b form, I would also get the same value. So going back to our slope-intercept, notice that the x and the y values that are in slope-intercept could actually represent your points, x1, y1 coordinates. So y I'm going to substitute in 1, m is 4, x is -3, and by doing that, notice now I have an equation with only one unknown, our b, or our y-intercept. So solving equations, I would have to multiply 4 times -3, which is -12, and then I would have to add 12 to both sides to solve for b. So I end up with 13 is equal to b, or 13 is my y-intercept. So making my substitutions back into slope-intercept, my slope is 4x plus then my y-intercept is 13. So notice, if I used slope-intercept form, I got to the equation y equals 4x plus 13. And when I used my point slope, I also got to 4x plus 13. Therefore, either method works. And at this point, my best recommendation would be for you to use whichever method that you feel the most comfortable with. And that concludes our podcast on parallel and perpendicular lines.